We have already seen about linear regression and logistic regression. Now we'll go into one more supervised learning technique. So that is nothing but k nearest neighbor. So basically, in short, it is known as KNN algorithm for machine learning. So the KNN stands for again k nearest neighbor itself. Now k is nothing but a placeholder. Okay, so it is a place from where you wanna get the surrounding or how you want to start with respect to the grouping. So which depicts the number of neighbors you want to take into consideration. So for example, you can take k as 3. Then what you are going to do is you are going to take the 3 nearest neighbors. Okay. So again, more insights about KNN. It is one of the simplest machine learning. So it is again based on the supervised learning technique. KNN algorithm assumes the similarity between the new case data and available case data. Okay, so it puts the new case data into the category that is most similar to the available categories. So KNN algorithm stores all the available data and classifies new point based on the similarities. This means when new data appears, then it can easily be classified into well-suited category by using KNN algorithm. And it is used for regression as well as for classification. So it can be used for both, but mostly it is used for classification problem over regression problem. Okay. So how do we measure which the closed elements is like? We use some distance to measure that. Okay, so maybe here we have an example. So again, KNN is a non-parametric algorithm, which means that it does not make any assumptions on underlying data. So in the previous logistic and linear regression, we had assumptions, right? So the both learnings or both algorithms. Over here, it has no assumption data, and that's why it is called as non-parametric. This one, and also it is also called as lazy learner algorithm. Okay, so because it does not learn from the training set immediately, instead it stores the data set, and at times of classification, it performs an action on the data set. Okay, so it is at the time of classification. Okay, so it is like the test set during test set or something like that. So it does not learn at the very beginning. So it is like not like the other machine learning algorithms or models. So basically here, that's why it is known as lazy learner algorithm. So KNN at training phase stores the data. When it gets a new data, it classifies the data into categories that is much similar to the new data. Okay. So that is with respect to classifier, and examples would be many things. So here on the right hand side we have this. So maybe you can classify with respect to straight lines, distance, or like that. Or you can consider this as our midpoint. From there you can have circles enclosed. So that will be like from this the nearest would be in particular circles and all. Okay. So again, let us see how do we use some distance measure to decide that. So we'll be using distance measures of KNN. First in is Euclidean. So Euclidean is the distance calculated through a straight line. Okay, so it is just a straight line between 2 points. So which is the shortest path? We'll be getting that particular as the closest similarities between two data points. And next is Manhattan. So here the distance is a summation of perpendicular distance. Okay, so basically we'll be getting horizontal lines drawn across the 2 points, and then we'll be getting the perpendicular distance. Okay, and final one is called as uh, Minkowski. So it is the distance between 2 points using a curved line. Okay, so let us see images which will give us more insights. So basically here we can see that Euclidean is directly straightforward. So one point to another point. So maybe you can consider this as a uh, hypotenuse with respect to Manhattan. Okay, so Manhattan is this distance, right? So if you are considering this as two sides, and this is the third side which will be connecting directly for these two points. So that is the hypotenuse. Okay, and that is for Euclidean, and for Manhattan it is like the perpendicular line. So as I was telling, we'll be drawing lines in such a way that both will form the lines will meet at a point where it is perpendicular each other. So that means it has a 90-degree over here. So it forms a right angle triangle if you get the hypotenuse or the Euclidean distance for them. So this is the second way, and third is Minkowski. Over there, you can see over here we have drawn a curve. Okay, so that is a again curve doesn't has any kind of a radius or anything. So it is just a basic curve which will be drawing. So that will be giving us the distance. So these are the three distance calculations. Second, with respect to a bit of calculation, so we'll have a model summary. So basically, the things what we will be looking out is precision. So what proportions of positive identifications was actually correct? Okay, so like we will be making again like kind of similarly classifications, right? So class A, class B, and all. So basically, here we need to see what kind of positive identifications were actually correct and what were incorrect. Okay, so we'll be concentrating on the positive things, and that is precision with respect to that, and recall. So what proportion of actual positives were identified correctly? Okay. So there or there in precision it was just like the positive identities was correct. Here what proportion of the actual positives what was identified correctly. Okay. So it is identified correctly means we will be ignoring all the false identities. So that is like the false negatives, right? So those things we will be ignoring, and we have something called as F1 score. So here it is calculated from the precision and recall of the test. So the F1 score is the harmonic mean the precision, harmonic mean of the precision and recall. Okay, so that is with respect to that. Maybe we'll look out formulas. Okay, so here precision true positive divided by true positive plus false positive. So I think everyone just recalls with respect to the confusion matrix what we are saw. So real versus true versus predicted table what we had seen. So true positive is actually the positive ones which are predicted correctly, and false positive are the ones which are actually false but detected as positive. So they are negative detected as positive. Okay, so that would be precision. And coming to recall, it is like a true positive divided by true positive plus false negative. Okay, so like we will be considering with respect to the false negative, which and all is not identified correctly. Okay, so the proportion total how many are positive and how many are detected with respect to positive. So this will be actually the entire true positives, but we will be getting only some portions predicted, not little, but it will be more like 80 90+% of uh, data which are predicted with respect to true positive. And next we have F1 score. So F1 score is, as I was telling, it was harmonic mean of between the precision and recall. So 2 into precision into recall divided by precision plus recall. Pretty straightforward formula what we have over here. And next we shall see an example. So here we are considering very less. Okay, true positive only one and true negative as 19. So margin of error is this 1 and 9. So here approximately we can calculate as 100 once, and we are getting 9 as the error. So with respect to the numbering here itself, I'm getting an insight that 91 are predicted properly correctly. So true positive and true negative, so they are predicted correctly and 9 of them is wrong. So that is almost like 91% accuracy. Okay. So we'll see precision. So what is precision? So that is true positive divided by true positive plus false positive, right? So precision is 0.5. And when it comes to recall, so recall is pretty low. So basically the true positive divided by true positive plus false negative, right? So that is 0.11. And coming to F1 score, so it is 2 into 0. Like this is both added up, right? zero point 0.5 and 0.11 is multiplied first and then divided by the addition of it. So product divided by the sum and then multiplied by 2. So F1 score is 0.18. Okay. So that is about a quick example with respect to what, and also I would like to give insights of how exactly it will work. So basically, we'll select a number of the neighbors. So then we'll calculate, maybe you can decide Euclidean distance. So based on Euclidean distance, you will find number of neighbors and take the k nearest value as per calculated Euclidean distance. Among these k, count the number of data points in each categories, and finally assign the new data point to the category, which is the number of the nearest to the neighbor is maximum. Okay, so number of neighbors is maximum. Okay, so then finally our model is ready. So it is not that complicated. And finally accuracy score, it is 91 by 100, so 0.91. So 91% accuracy. So it is straightforward. You just calculate, you just add true positive, true negative divided by all four. true positive, true negative, false positive, and false negative. So we have a few more extra information about KNN. So basically, first we are seeing about grid search cross validation. So here, this is a hyperparameter tuning method where you put in all the parameters values that you want to train and test. Okay, so everything will be put down to your model with, and on the basis of that you get a combination of values passed and you select the best out of it. Okay, so you'll just put down everything and you will get some kind of combination of these values passed, and you will select the best out of it. Okay, so again we have random search cross validation. So these are like the pre-processing. So this is similar to grid search, but doesn't make combination of all the values. Okay, so it makes a combination of the values that are most likely to give better results. Okay, so this is actually the best for larger data sets and has more number of features. Okay, features, parameters, maybe columns, all these are interchangeably used, so they mean one in the same. Okay, and we have k-fold, so most likely we'll be using k-fold in most of the cases, as I have come across in my personal experience. So k-fold and stratified k-fold cross validation. So in k-fold we basically fold our data like set k times and do the training on the test data set. Okay, so this gives us k number of accuracies. Okay, so now you can either look at the range in which the accuracies lie, or just have an average accuracy. Okay, so I think it is best to look at the range in which the accuracy lies. And stratified k fold CV is just an extension. So here we are talking about like previous point talked about k fold. Now stratified k fold cross validation is just another extension as same as old k fold. The only difference is that the data over here is stratified. Okay, it has an equal proportion of class distribution in both the training and test data set. So we are already seen what exactly is stratified in the logistic regression itself. So that's all with respect to KNN or K nearest neighbor. So in the next session, probably we'll learn about naive bias. So another classification one.